coming up. Okay. Example 2. In the bottom of the 9th inning, a player hits in the bottom of the 9th inning, a player hits the .15 kilogram baseball over the outfield fence. The ball leaves the bat with a speed of 36 meters per second, and a fan in the bleachers catches it at 7.2, above a point where it was hit. Assuming frictional forces could be employed, find the kinetic energy of the ball when it is caught and the speed when it is caught. Let's make sure we understand frictional forces being neglected. Conservative system. There is going to be friction, there's going to be air resistance, but we are pretending we live in a perfect world. Okay, this is so exciting. Also, something I had to wrap my head around, angles don't matter. When they tell you the velocity of the ball, that's when you do 1/2 mv squared, but then in for v squared. It's the diagonal. It's the magnitude of the actual diagonal. So don't be like, I wonder if I need to make that x, or if I need to make it y, or do I leave it what it is? If it tells you the velocity is 36, this velocity, see this velocity vector? That's 36. So I care about it right here. The velocity right here is 36, so leave it alone. That's the initial velocity. Okay, so I already labeled that. Initial velocity is 36. Clearly the velocity goes down, right guys? And eventually the velocity turns into a negative. All right, look where they're putting our x-axis. What is the initial height?
0.
Good. 1/2 mv squared. What's m?
0.15.
Good. Okay, so there's 1/2 mv squared on that side. Let's do 1/2 mv squared on this side. So do I know my final velocity? No. Do I know my final height? What is it? 7.2. Just double checking, above where he hit it or above the ground? Above where he hit it. Okay, good. That's an important phrase there. Because if they said above the ground, we have to know how far above he hit it. So that's above where he hit it, the ball, and I do know my mass is what? Good. It's the algebra teacher in me. Nothing makes me happier than doing this problem. All right? So if we are in a conservative system, we need to find the kinetic energy of the ball when it is caught and the speed when it is caught. We can do that we can do those, I think we can do B before we do A, or we can do A before we do B. That's fine. Here's what I would suggest doing. If you know it's a conservative system, I would go straight into this. I did pretty much the majority of my homework like this. I'm like, I love my formula that works all the time. Right? Don't you guys? Beautiful formula. So I need 1/2 mvi squared plus mghi equals 1/2 mvf squared plus mghf. Do all my i's and f's and h's and stuff make sense? Such an algebra problem. Yeah, but again, that must be why I love it. So 1/2, you guys can do this without me. I have full confidence that is the truth. Should I be saying it out loud, or are you okay?
9.8 or negative 9.8?
9.8. Yep, we're not talking about the acceleration, we're talking about the magnitude of gravity. Yeah? Excellent question. You guys can just see, like, this is where I hit my stride. This is my comfortable zone. Look, I put my paper down. Use your algebra skills. Can I show you guys something that might be helpful for your homework? What if we didn't watch? What if we didn't know the mass of the ball? Can I show you? This has an M. This has an M. Isn't that crazy? You don't even need to know the mass of the ball to figure out. Well, you need it to figure out the kinetic energy. But I don't need it to find the final velocity, which is kind of cool. So you can eliminate the 0.15, keep it in there, but I just want to let you know, you could, for what we're doing, take out the 0.15. The last problem I didn't, because they wanted to know the individual spots of what it was to prove it. You could have just proved ki plus ui equals kf plus uf and said, hey, look, both of these sides are the same. Oh, could we have done this? No, because we didn't have the VF squared. We didn't have the VF squared and we didn't have something else. Acceleration, we didn't have, there was something we didn't have. What were they trying to find? The final, we were trying to find the. So we couldn't have done, there you go, you couldn't have had these K's right here without knowing that V. You would have to know what the original velocity is, which we do. We'd have to know the change. We would have to know the acceleration of gravity. Oh, I think we might be able to.
I just did it.
You did it? Okay. Oh, that's fun. I like that. I like that a lot. So Rose is saying, could we use the v squared equals VO squared equals 2?
Whoa.
Oh! Well, Rose was thinking that at home, Olivia. I'm not going to make eye contact with you. I'm just going to write VF equals, I'm going to awkwardly pretend like I didn't do that. I love you. If you want gum or chocolate or a hug, don't let me hug you. I feel like I might have a coronavirus. Just joking. Air hugs. I know. I hugged somebody yesterday. I'm like, I don't think that was a good idea. I'm a hugger. I like to hug. We doing okay back there?
Yeah, you just got another possible scam call.
What's that?
I said you just got another possible scam call.
Oh, I'm sorry. One day, in this block alone, I had 10 voicemails that were each 1 second long.
Yeah.
Did anybody? I've been really taking my time up here. Did I get the final velocity?
Was it 4.3?
3398.
Oh.
I can come look at your calculator.
If you had 1, 2.
I do. I went, hey guys, we solved for part what? We solved for part B. Can you guys solve for part A? Part A, what's the kinetic energy at that spot? 1/2 mv squared, please. So 1/2.
No, now we're doing
Yeah, now we're doing part A.
What was that number?
It's
I
literally,
think someone coughed.
I think some dog used to chill out in my house back with this skunk.
Go down.
I think I went.
Yeah.
I think I went.
Look
high
good.
enough. So I guess that's what I said.
Okay, so 1/2.
Officially certified as a.
I
I
didn't
think
bother.
you wanted that to be a plus.
Oh, I didn't bother typing in the sections, but I'm always zero.
Oh, okay. Oh, so then you divided by.
I divided the. Oh wait, no, I'm wrong. Yeah.
It's almost. Oh my gosh, it really is. But hon, this will get you through literally. There's only one more. Well, there's a few more. But hey, it will be recorded. What was it? 86. Is it 62, Mr. McLeader of 62?
0.60. Yeah.
Okay.
Socks.
Oh my gosh, it's totally on record back there. Okay.
Put it on YouTube.
9 or example 3. A 55 kilogram skateboarder. Let's write M equals. Let's get you guys through this so you can work on some stuff. M equals 55. Enters a ramp moving horizontally with an initial speed. I inserted the word initial, and leaves the ramp moving vertically with a speed. So that's the end. That's the final. Because he's leaving the ramp. Find the height of the ramp, assuming no energy lost due to friction. So, no energy lost due to friction?
So there was no Y0.
Yes.
See ya.
Bye, have a good day.
Thank you, you too.
Me too. Okay, what is, I'm just gonna go for it, I'm not gonna write the whole formula. What is the mass? Good. What is the initial velocity? Good, we're gonna square that. Not gonna forget that one, Jelly. Plus, what is his mass? Times gravity and the beginning height. Good. Equals 1/2 his mass times his final velocity. Good. Times squared. Thank you. Plus his mass times his. Thank you. Times an unknown h. Solve for h. Use those algebra skills.
So do we use it as like a change? Do we use it as a change? You know what I'm talking about?
No.
Can I do that?
On this one,
That's great.
Like a change in y, we use it like y, like the x
there's a good
minus,
chance that will work.
x minus the original 0.
I think you can.
Alright.
Wait. I don't know, Rose, because I did it again, but I caught it. I don't know, Olivia, because his velocity is 4.1 in the horizontal, not in the vertical.
Can I try it?
Yeah, but make his vertical velocity 0.
So would be
In your equation, what you're doing, if you're doing like v squared equals vo squared, I think vo squared would have to be 0. Because you would have to do it in the y direction, because that's not a two-dimensional formula. That'd be interesting. I'm waiting.
1.298.
Okay. Awesome. I really just need to unstable this and restable it. What is my
That's
problem?
even a dog for Sarah.
It is Adam. He does it on the track.
Any questions from anybody?
How are you doing?
I'm doing well. Thank you.
Yeah, why are you doing well?
What did you get? H equals what? Listen, I can't do it.
Why?
Because that's an adjective. And if you're saying I am, that's the predicate noun, so you use values. Wow.
You don't have to be just like this. This means you're a math teacher. You don't have to do this. Just embrace your life. Okay?
You know what's like is to write with both hands at the same time.
I can
Shouldn't you
too.
be great papers at the same time?
Can too. I mean,
Meet me in person.
Oh, yeah, no. All right. Hey, they're going to get more difficult, so put your big girl and big boy pants
I
on.
was like, I don't know, buddy.
Hey, 1.7 kilogram block slides on a horizontal, frictionless, Dad,
Yeah.
surface until it encounters a spring with a force constant of 955 newtons a meter. The block comes to rest, important, after compressing the spring, a distance of 4.6 centimeters. We all know how to get to meters. Find the initial speed of the block. Ignore air resistance and any energy loss when the block initially contacts the spring. So we are in a conservative system. Ki plus Ui plus Kf plus Ui. 1/2. Tim, what's the mass?
1.7 kilograms.
Times the initial velocity.
Well, it's 0.
No, it's definitely moving.
This
It
is
says it's,
velocity equals 0 and we'll return.
Yeah, but that's after.
yes, that's after it's been compressed. So the initial velocity is unknown. If I'm not mistaken, it does say find the initial velocity. Plus, hey guys, I'm gonna write MGH, and then I'm gonna pick up my eraser and erase it when someone tells me why it's not MGH.
Because it's like gravity.
Yeah,
Only ground.
because it's not. But there is potential
It's a
energy.
last.
That's not flying.
It's not in the air. It's not. But there's a different type of potential energy, and that potential energy is elastic energy. Okay. So instead of MGH, because we don't have gravitational potential energy, we have 1/2 kx squared.